Okay, today we are doing this lesson here using linear regression to find the line of best fit, and we're going to use a calculator to do it. And what we've done so far is we visually determined a line of best fit. So for example, if we get a scatter plot like this, for example, it gives us various data points, and what we'd like to do is we'd like to find a way to put together a model where we can make predictions on other ones. So for example, if we one of the things that we learned before is what we can do is kind of put a border around the actual data points that we have, like that, and then a best fit line would kind of split those down the middle, maybe something like this. Of course, it would be a straight line, and my drawing's not so great here, but the point is you're going to make a line like that, and what I'm going to do is and then of course from there you can make predictions. So for example, we've got data points over here, but let's say for example I wanted to know what the predicted temperature would be, or not temperature but the sales in this example here, if the temperature is 21 degrees. Well, it'd be right here. I don't have any data points, but I would use my best line to say, well, the best prediction would be about right there, which would be, I don't know, in between 400 and 500. I don't know, maybe for example 450. But that's how we could use it. Now there's a better picture over here, if I scroll down a little bit, where they put a nice straight line. Again, if it was at 21, it would be about, well, here a little bit higher. But hopefully you get the idea. But that's what we learned before, and we were doing it using visual estimation, although we could figure out the line for that. What we're going to do today is we're actually going to put together a line using a graphing calculator that takes all these data points and calculates exactly what line would be the best predictor of the relationship based upon the data that we're given. So first thing we're going to do is we look at it. We need to get a calculator, a graphing calculator to do this. And so why don't we go ahead and open up this, and that'll show us the steps that you go through. It's similar to what we did when we were doing a linear regression for standard deviation. We did that in a few lessons ago, but a little bit different. So I'm going to go through the steps. But of course we need data, right? So if we're going to enter in data as one of the first things. So I'm going to go ahead and get the data, and that's going to be in the assignment. So that would be over, one moment. So now we got to go back and open the assignment link, and got it. Okay, so here we have this should be the assignment that you see, and the first, we're going to go ahead and do questions 1 through 9 in this video. And if you need to do translations, make sure you do that so you understand what they're saying. But basically what we have in this case scenario is we've got months, number of months after a given starting date. So 1 month after a particular starting date. We don't know what it is, what time of the year it is, but what we do know is there's a maximum temperature 1 month after that starting date of 106. After 2 months, 85, etc. So basically this would be your x, or your independent variable. This would be like your y, but in this case it's months for m and t for temperature. Okay, so what we're going to do is we're going to enter this data into a calculator and run a regression of a best fit line, and then use it to answer the questions 1 through 9. So the next thing we'll need to do is get a graphing calculator. Either you can get one on your desk, or if you prefer, you can use the online graphing calculator, which you'll probably want to do if you're at home, since most calculators don't have this feature. So click on that and open up the graphing calculator over here. Get rid of this ad for a second. Okay, so what are the steps? Well, if we look over here, it says we should turn the diagnostic. We have to do something 1 time, okay? So first and remember, the keys over here, like a 7 or this key over here, basically these are the main keys you need to know, have brackets around them. So the first thing you see is second. So I'm going to go over here to my online calculator, and I'm going to hit second. And then what next? 0. And then scroll all the way down to diagnostic on and press enter twice until it's done. So second, I already did that. 0. Next, 0. Okay, we're going to scroll all the way down to, just hold the down arrow, okay, until it gets diagnostic. And it should be on, right? I think that's what it said. Yes. And we're going to hit that twice, enter, enter again, and now we're done. Good. Okay, so we did that. Only have to do it once when you get your calculator. Okay, now we're going to enter the data. So like before, when we learned with standard deviation, we go stat 1. So stat 1 allows us to enter the data. If I'm going to kind of quickly go through this because I'm assuming that you did the standard deviation exercise that showed you how to enter in data. But I do want to do a reminder and tell you that you have to clear out the data. Remember, what you want to do is you want to get the cursor, or this thing blinking, in the column header where there's data. There's data here, and then hit clear, enter. And there's also data here, so I'm going to go up like this, clear, enter. Now, one thing that's different is we've got 2 columns that we need to enter in. We've got the months, so that's going to go in the L1 or the first column, and then we got the temperature. So remember, if you remember from the last exercise, I have 1 is the first month, enter, 2, enter, and then when I enter in, I'm not going to make you watch me enter all the rest of them in, but that's from the months. But I also need to do the temperatures over here. So what was the first one? The first one's 106.85. So now I use my arrow keys. 106, enter, oops, 85, enter. Okay, so I'm going to pause the video and enter in the rest. And when I'm done, I'll go through this. Okay, so after you've entered in the data, and by the way, you should hopefully be doing questions 1 through 9 together as we go through this and making sure you enter in the data. Double check to make sure you entered in correct. So we got that. Okay, what do we do next? We've entered in the data. Okay, it did say to check for old data. We cleared that out. We entered the data. And now we're going to perform the linear regression. So here's the things we go through here. We hit stat, the right arrow, 4, enter, to choose linear regression, then hit enter. Hit enter again, highlight calculate, and then hit enter again. So I'm going to go through these steps. So we go to stat. Now we need to highlight this calc, so we use the arrow key, highlight it, and we're looking for linear regression from the menu, which is number 4. So hit 4, and then we need to scroll down to calculate with the arrow keys, enter, and what do we get? Well, we get this output right here. So let me explain this a little bit. We've been doing a lot of linear functions, and the generic function has been y equals mx plus b. So we've been doing linear equations, and this is what we're used to, right? Y equals mx plus b, with m being the slope and b being the y-intercept. Well, if you look at this right here, this is the same thing, right? The difference is, instead of having an m, we've got an a, but it's the same thing. So a equals the m for the calculator, okay? And then the b is the same. The same right here is this. That's the same as that b, so that's the y-intercept. So what does that mean? It means that the best fit line in this case would be, a would be the slope, so it would be y equals, okay, I'm going to just go ahead and round this to a decimal, so negative 7.5x. And then the y-intercept is 116, so that's going to go up here. So that's going to be plus 116.8 or 9, close enough. And that is our best fit line right there, okay? So that's the best fit line. So now we can actually answer the first question of the assignment. Okay, so which one of the choices where did that go? There we go. Which one of these matches the what we got? Again, we got, where to go? Where are you? We got negative 7.5 plus 116. So that would be, yes, that's good. Plus 116. Okay, so that's going to be A, right? So that's how you do that one, okay? The next thing is, what is true regarding the relationship between temperature and months based upon a table? Okay, is there a negative or positive relationship? Well, the slope tells us that, right? The slope says that, so if the slope is negative 7.5, that means there's a negative, so yes, 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 maybe, but definitely not B. It's not positive. The next thing is the remaining choices have a correlation. Well, what is a correlation going to be? Okay, well, we can tell from our readout that it lists the correlation. Now, it's important. There's an R squared and there's an R. The important one is this one. The R is the one that we need. And what does it say? Negative 0.92 with a bunch of other stuff. But basically, this is the one we need. We need the R. That's going to be the correlation coefficient. Okay? That says how strong the relationship is. So it's very strong. Remember, negative can be strong. Closer it is to -1. -1's perfect, just like 1's perfect. But so it's a negative 0.92. So that would be the answer for question number 2, which is going to be this one right here. Okay, two things: negative relationship we get from the slope, and we get the negative 0.92 from the calculator readout. Okay, great. So now we can use our best line fit, which is this right here, choice A, to start answering these. Now all we have to do, let's see, use the best fit line model or line of best fit. What would the predicted temperature be after 3 months? Okay, now it's very important that you don't just say, hey, 3 months is 103. First of all, it's not on there, so that would have been a tricky trap answer, I guess. We have to use the equation, okay? Okay, so when we use this equation up here, I've written it down here so you can see it. And instead of the M for months, I put in what the 3 months is. So that's going to give us, that goes right there. We multiply it out, and when we do it, we get the following answer. Okay, so I got negative 7.5 times 3 plus that, and I got 94.4. So that's going to be answer A. Okay, so this one I'm still using the same function, but now I'm going to be plugging in 15 here, and the answer I get is going to be 4.4. Okay, question number 5. What is true when it comes to using the model to predict temperature on the previous 2 questions? Well, basically it comes down to, are we using interpolation or extrapolation, and which one is more reliable? Just a quick summary. We did this earlier in the trimester, but basically interpolation is when you're using data, or you're making predictions based upon data with that you already have. So we've got data between months 1 and 10. So if somebody says, what is the, if we're using 3 months, that would be interpolation because it's within the data that we have. It's not extrapolation. Extrapolation goes beyond the data. So 15 months, we don't have it yet. That would be down here. We don't know what it is, but it goes beyond the actual data we have. So 15 would be extrapolation. So that means that these are out still. Okay, that means we still are down to A and what? And C. Both are correct here. The issue is what's more reliable, interpolation or extrapolation? Well, interpolation is always going to be more reliable, so the answer is A. And again, as a quick reminder, it's more reliable because we have actual data for these 10 months, and so making a prediction during that time, at least it's based upon data that we have. When we start going beyond it, we don't have any data. We're just assuming that the pattern would continue that we've been able to identify in our model. So that's why interpolation is always going to be more reliable. Okay, so I'm already at 14 minutes on this video. Sorry for the long video, but I don't want to rush through the next 4 questions. So I'm going to make another video. It should be pretty short. These are actually pretty quick, but please refer to the next video for questions 6 through 9 and to finish those off.